Hi everyone and welcome to Moore's Law by me, Kelsey Naked. Prepare to be amazed, wowed. So what is Moore's Law? Moore's Law states that the number of transistors in a dense integrated circuit doubles about every 2 years while the cost of computers is halved. So Moore's Law states basically that we can expect an increase in the speed and capabilities of computers while we pay less for them. Though Moore's Law is called a law, it is not a proven law or scientific law. For example, E is equal to mc squared. It was solely based on observations by Gordon Moore. So on the right, we have a graph, and the graph shows the exponential increase in the transistors per chip. Who invented this law? The law is termed Moore's Law as it was created by Gordon Moore. In 1965, Gordon Moore was the Director of Research and Development at Fairchild Semiconductor. He was asked by Electronics magazine to predict what was going to happen to the semiconductor components industry over the next 10 years. He noticed that the number of components, for example, the transistors, resistors, diodes, or capacitors in a dense integrated circuit had doubled approximately every year, and he speculated that this would continue to do so for at least the next 10 years. In 1975, he revised the forecast rate to approximately every 2 years. Gordon Moore then went on to be the co-founder of Intel Corporation. So far, we've described what is Moore's Law, but what relevance does Moore's Law have? Why is it so important? So Gordon Moore's prediction became a self-fulfilling prophecy that emerged as one of the driving principles of the semiconductor industry. It basically challenged technologists to deliver annual breakthroughs to ensure compliance to this law. Additionally, Moore's Law highlights the rapid change in information processing technology. So on the right, we can see how far computers have come to the present day and how different the first computers looked to the MacBooks or the HP laptops or the Lenovo's that we use today. So for the past 5 decades, Moore's Law has held up pretty well. Roughly every 2 years, the number of transistors that could fit on a chip doubled, all while cost steadily declined. Today, however, transistors and other electrical components are so small, they're beginning to bump up against fundamental physical limits on their size. So on the right, we can see a graph, and the first transistor was about 1 centimeter. However, in 2020, transistors became 1 to 5 nanometers, which is extremely small. So unfortunately, there is a limit to Moore's Law as transistors cannot get much smaller. So when will Moore's Law end? I alluded to this in a previous slide, but due to the physical limitations on Moore's Law, many forecasters, including Gordon Moore himself, have predicted that this law will become obsolete by 2025. But this is not the end of technological advancements. Advances in artificial intelligence and quantum computing will make up for this. Unfortunately, we've reached the end of the presentation, so just a summary. Moore's Law was a breakthrough law at the time that predicted the future of integrated circuits, and rightly at that. Unfortunately, all good things must come to an end, but even after Moore's Law becomes obsolete, we cannot take any shine away from this law because it basically shaped technological advancements for the past 6 decades. Thanks so much everyone for listening. I'm Kelsey Nackett and I'm out.